Greeting of the day. Today's topic is function of complex variable. So as we know that many engineering problems are treated and solved by the method of complex number and complex functions. There are two kinds of such problems. The first of them consists of elementary problem, for which the knowledge of complex number is sufficient. This includes many applications to electrical circuits and mechanical vibrating system. The second kind consists of the more complicated or advanced problem, for which we must be familiar with the theory of function of complex variable. Now, the complex function theory or complex analysis is one of the powerful and elegant method. Interesting problems in heat conduction, electrostatic and fluid flow belongs to this category. We shall see over here the importance of complex analytic functions in the engineering mathematics, which has two main roots. The first one is the real and imaginary parts of an analytic functions are the solutions of the Laplace equation in two independent variables. Consequently, the two-dimensional potential problems can also be treated by this method developed for analytic functions. The second root is that most of the higher functions in engineering mathematics are analytic functions, and their study for complex values of independent variable leads to a much deeper understanding of their properties. So, complex integrations can be evaluated with the help of the theory of function of complex variable. So, let us begin with what is the function of complex variable. So, here we may need some of the elementary concepts, right? We may need some of the elementary concepts which will come across throughout this unit. So, what are these elementary concepts? So, first we need the definition of complex variable. Right? So, as we know, what is meant by complex number? Complex number is nothing but ordered pair of the two real number, right? Ordered pair of two real numbers. So, this is the ordered pair of two real number where x and y are nothing but a real numbers, which can also be written as x plus iy. So, therefore, z equal to x plus iy, or this ordered pair is nothing but a complex number, right? Now, so how will you define a complex variable? So, here I am treating x and y as a complex number, right? So, how will you define the complex variable? So, it is done in a very simple way, right? So, in place of a number, what we will take? We will take it as a variable. So, what will be definition of complex variable? It is nothing but ordered pair of two real variables. Ordered pair of two real variables which takes the real value, right, is called as a complex number, right? So, obviously, so hereafter whenever I write z equal to x plus iy, so it is considered that x and y are nothing but a real variable which takes a real value, right? So, I hope this definition is clear to you all. Let us move to the next one, next part, that is function of complex variable. What is meant by a function of complex variable? So, the definition of function of complex variable is exactly similar to the definition related with the function of real variable, right? So, what is the definition of function for a real variable? So, if for a given value of certain variable we get two or more values for the another variable, then the rule which associate these two variables, that is nothing but called as a what? A function, right? So, how will you define function in complex variable? So, if for each value, if for each value of the complex variable, if for each value of the complex variable, that is say z, in a given region, R, we have one or more values. We have one or more values of another variables, say omega. Then omega is said to be a function of complex variable. Right? So omega will be called as the function of complex variable. That is, we write omega is a function of a z. So what is f? F is a rule which associate one variable which is a complex with another variable. Right? So both this omega and z are nothing but a complex variable. Right? So what this means? Let us try to understand this with the help of a diagram. Right? So what we have? We have a rule. Right? So rule is just acting like a machine. Right? Here I would like to take the example of flour mill. Right? So this machine is nothing but a flour mill. Now, for getting a wheat flour, right? So what is the output? Output is nothing but a flour, wheat flour. Now, for getting a wheat flour, what is required? That we need to insert a wheat grains, right? Wheat grains to the machine. Machine is nothing but a flour mill. So processing is done. And after processing, what we get? We get a wheat flour, right? So what is input? This is nothing but a input, right? And this is output. And this is being processed through this certain rule, which is acting like a machine, right? So this is nothing but a function. So in our example, what will be input? Input will be z. That is a complex variable, right? So which we have written as x plus iy. Now this goes to a rule. It goes inside the machine, right? So that machine is nothing but this rule, function f, right? So processing will be done, and accordingly we will get the output. What will be output? Output will be f of z or omega. And this is also what? A complex variable. So this we usually write as u of xy plus I v of xy. Isn't it? Right? So like this, the function of complex variable is defined. Right? Let us take one simple example. Suppose I have to find out the now you must be having one question. Why I have written f of z as u of xy plus I v of xy. Right? So here what is u? U is a real part of this resultant function. And what is v? V is a imaginary part. Right? And you observe that u and v both are function of x and y. And what is x and y? X and y are real and imaginary part of this input function, that is z. Okay. So you may be wondering why I have written, is it true? Right. So let us try to verify this with the help of one example. So let us say if I am having a function as f of z is equal to z square. So what we wish to find out? We wish to say that its real and imaginary parts are nothing but a function of x and y. Okay. So what I will do? As I know that z is nothing but what? X plus iy. So let us put z as x plus iy. So it is x plus iy whole square. right? Now expand this by using the formula a plus b whole square. So what you will have? It is x square, then plus 2i xy plus I square y square. Okay. Now, what is I square y square? I square is nothing but what? I square is nothing but minus 1. Right? I square is minus 1. So let us put I square as minus 1 over here. So this becomes minus 1. So let us collect the real part, means the term which is not containing I. So it is x square. This will become minus y square plus I times 2xy. So what you will find? This is completely a real, not containing I. So this is real part. So this I can denote as u of xy. You will find that this is a function of x and y. Similarly, this I, what is left? This is also a function of x and y. So I'll write it as v of xy. So what we are finding here? That u of xy is x square minus y square and v of xy is 2xy. So in this way we will get the what? The real part and imaginary part of a given function of the complex variable. So I hope this concept is clear to you all, right? Let us move to the type of function of complex variable, right? So generally we have two types of functions. One multi-valued and another is a single value, right? First is multi-valued and second is a single value, right? So let us take what is single valued function. Right. So what is mean by single valued function? So if for each value of z you will get only one value for omega. If for each value of z you will get one value of omega, then that function is said to be a single valued function. Right. So let us see the definition. So a function omega equal to f of z is called as a single valued function if omega has one and only one. Omega has one and only one value for every value of z. Right, so remember omega has one and only one, right? Value for every value of z, then it is called a single valued function. For example, omega equal to z square, right? So this is a single valued function, right? Why? Because let us take, suppose we have 2 square, z is 2, so 2 square. So what will be omega? Omega will be only 4, right? If z is 2, so omega will be 4, only one value. So that's why this is a single valued function, right? The next is multiple valued function. Next part is multiple valued function. So a function, what will be the change? So for single valued, what we have? Omega has only one value, right? For a multiple valued function, what will be the change? That instead of only one value, it may take more than one value, right? So a function omega equal to f of z is called as multiple valued function if multiple valued function, if what, omega has or omega takes more than one value, for each value of z. Right? So what will be the example? Tell me. So example is omega is equal to root of z. Right? Omega equal to root of z is a multiple valued function. Okay. So you can check this. Suppose I will take omega as 4, z is 4. So under root of 4 is what it will be? It will be plus minus 2. Right? So how many values omega is taking? 2 values. One is plus 2, another is minus 2. Right? Isn't it? Okay. So like this we have definition, that is types of function. One is single valued function and another is multiple valued function. Let us have the next one, that is path of complex variable. Now what will be the path of complex variable? So as we know in a real variable, right? As we know in a real variable, the independent variables takes values corresponding to the point on the x-axis, right? In real variable, the independent variable takes the values corresponding to the points on x-axis. But in case of function of complex variable, right, the variable z may takes the value in the plane, called as a z plane or Argand plane, right? Called as a z plane or Argand plane. So the path of complex variable is either a straight line or it may be any curve on a z plane or xy plane or Argand plane, right? So on a real variable, it is always the path of a independent variable x is always along x-axis, or we can say always along a straight line. Whereas in case of complex variable, the variable z takes the value either on the straight line or it is along the curve which is on the Argand plane or the z plane or xy plane, right? So these are the differences. Now the next, let us discuss. So as we know that in this unit we are going to study the calculus of function of complex variable. Now what this calculus means differentiation, integration, limits, continuity, all these are nothing but comes under the calculus. So let us see the first part of this, that is the derivative of analytic function, right? So what is mean by derivative of the function of complex variable, that we are going to study in this. So how to define just recall how to define a derivative in case of real variable, function of real variable. Yes, how to define derivative in case of function of real variable. Yes. So it is, we know that for real variable we write f dash of x as what? Limit, then delta x tends to 0 of f of x plus delta x minus f of x upon delta x. Where what is delta x? Delta x is a small increments in x, right? Infinite sample increments in x, right? So when this value tends to 0, we have a derivative of function of x. Just like this, we can define a function of complex variable. So in place of real variable, what we will do? We will take a function of complex variable. So its derivative is denoted by f dash of z, or we can also denote its derivative by d omega by dz. So that is equal to, it is nothing but limit delta z tends to 0 of f of z plus delta z minus f of z upon delta z. Right? So we will give increment to this z in this function. So it is f of z plus delta z minus f of z upon delta z. Right? So like this, the function derivative of the function of complex variable is defined, provided the limit must exist. Right? This will be called as a derivative provided limit exists. Right? If derivative does not exist, it won't be called as the derivative of the function. Right? Now let us come to the most important part of this unit, that is analytic function. What is meant by analytic function? Right? Analytic function. So in case of real variable, we can find out the derivatives by using this first principle, right? But for a complex variable, even though we have suggested this, but we find this difficult, right? We find this difficult. So the concept of analytic function and Cauchy-Riemann equations is required. So what is analytic function? So a single valued function f of z in a region R is said to be analytic. Or also called as regular or holomorphic. Or another word is monogenic. Right? So a single valued function f of z is said to be analytic, regular, holomorphic or monogenic if it possesses a unique derivative. Right? If it has a unique derivative in a given region. At all the points of the given region. Right? So what is the requirement when it is said to be analytic function? If a function is differentiable at each and every point of a given region, then it is said to be analytic. Right? A point at which function is not analytic is called a singular point. Right? A point at which function is not analytic is called as a singular point. So obviously let us try to find out the derivative according to this definition, right, which we have mentioned, I have suggested earlier. So let us try to obtain the derivative. Let I take function first. Say I am taking a function as f of z equal to z. Right? Let us find what will be its derivative. So according to this, we need f of z plus delta z. So therefore f dash of z will be limit delta z tends to 0. So if f of z is z, what will be f of z plus delta z? Just replace z over here by z plus delta z. Okay. So what it will be? So substituting f of z plus delta z and f of z equal to z in this equation, say equation number 1. So what we have? Z plus delta z minus z upon delta z. So this z will get cancelled, delta z will also get cancelled. We are left with limit as delta z tends to 0 of 1, which is nothing but 1. So what I am getting? The derivative of f of z equal to z is 1, right? So this matches with our usual differentiation formula, that is derivative of the real variable, right? If I have f of x is equal to x, its derivative is what? Its derivative is 1. So similarly here also I am getting, if f of z is z, I am getting its derivative as 1. So shall we draw the conclusion that the differentiation, whatever differentiation formula are there for a real variable, same will be applicable for a function of complex variable? So the answer is no. So there is a contradiction, right? So I'll try to explain this with the help of one example. Suppose in place of f of z as z, if suppose I'll take z bar, right? What is z bar? Z bar is nothing but a conjugate of z. Okay, z bar is a conjugate of z. So f of z plus delta z will be this z plus conjugate of z plus delta z, right? So we will have z plus, we will put in equation 1. So we will have such type of terms. Okay, now, so what will be the conjugate of z plus delta z? So as per triangle inequality, the conjugate of z plus delta z is less than or equal to conjugate of each of the terms, that is conjugate of z plus conjugate of delta z minus conjugate of z upon delta z. So what you will find here? This will get cancelled and we will have the values less than or equal to, right? What will be the conjugate of delta z, that you can find out. So here we are not getting the value equal to, we are getting the value less than or equal to. So in this way we will find that the formula which are applicable for differentiation in case of real variable are not exactly implemented in case of function of complex variable. So we need a tool which will guarantee us regarding the existence of derivative, as well as which will give us the formula to find out the derivative directly. So that tool is nothing but the Cauchy-Riemann equation. So let us see what is Cauchy-Riemann equation. Right? So Cauchy-Riemann equation is the condition which speaks about the existence of derivative of function and with the help of which we can get the derivative as well. So what is the equation? So if we have, suppose f of z is equal to u plus iv, where obviously u and v are function of x and y, right? Though I am not writing u of xy plus iv of xy, but it should be kept in mind that these are function of x and y, right? So f of z is u plus iv is a function which will be analytic if right. So when it will be analytic, if what we have derivative of u with respect to x is same as derivative of v with respect to y, and the derivative of u with respect to y is same as minus of derivative of v with respect to x. So this is what we have is Cauchy-Riemann equation. So this is called Cauchy-Riemann equation. In short, we write it as CR equation, right? So if any function satisfies this condition, then it is said to be analytic. Okay, any function is satisfying this equation, then it is said to be analytic equation, analytic function, right? How to remember this equation? It is very easy, right? So real part is u, find its derivative with respect to x, right? Then what we will do? Replace u with v. Just replace u with v and interchange x with y. So we have y. So derivative of u with respect to x is del v by del y, and now as we have already derivative of u with respect to x, so in the next equation I will take derivative of u with respect to y. Now this needs to be equated with the derivative of v. So we write del v and then again interchange y with x. So we have x and assign minus sign, right? So in this way one can remember this equation, that is CR equation, right? So the necessary condition for a function to be analytic in a given region is that it should satisfy the CR equation, that is Cauchy-Riemann equation. Note here the derivative of the definition of derivative, a function of complex variable, is identical in the form to that of derivative of function of real variable. Hence, the rules of differentiation for a complex variable are same as those of real variables. Once it is identified, the function is analytic, that is, it is differentiable. And how to check whether function is differentiable or not? So that we can verify just by checking this condition. If this condition equation is satisfied, then the function is said to be analytic. So once we find it analytic, then we can differentiate any function in an ordinary way as we used to do in case of the real variable. The another function is that the analytic function is always differentiable and continuous. Note important thing, that analytic function is always differentiable and continuous, but the converse is not true, right? But converse is not true. And the next point that we have is that the Cauchy-Riemann equation is used as a test condition to determine whether a given complex function is analytic or not, right? Once we get an analytic function, then how to find a derivative? So that is obtained by this formula, that is f dash of z is equal to del u by del x plus I times del v by del x, right? So once we will come to know that the function is analytic, then we can find its derivative by making use of this formula. So remember what it means. So whenever function is analytic, so it means what? CR equation is satisfied, right? And when CR equation is satisfied, it means what? Function is analytic. So it is both way, right? So if function is analytic, means CR equation is satisfied, and if CR equation is satisfied, then function is analytic, right? But if suppose CR equation is there and if we will add the condition of continuity, right? If we add the condition of continuity, then that condition is called as the analyticity, right? Then we get analyticity. So in this way we will get what we have learned in this video, that what is mean by function of complex variable, then what are the types of function of complex variable. Along with that, we have seen the path of the complex variable, and then we have gone through the concept of analytic functions,